Hello, good evening, Sarah. This is Dr. Sarah Myhill. The GNC is holding another of its webinars, and we're delighted to have Dr. Sarah Myhill with us today. And I'll just introduce her briefly, and then she'll be talking for about an hour. And there will be a couple of questions at the end. And of course, do write in with any further comments or questions that you have. So Dr. Sarah Myhill qualified in medicine with honours from the Middlesex Hospital Medical School in 1981 and has since focused on identifying and treating the underlying causes of health problems, especially the diseases of civilization with which we are beset in the West. She's worked in the NHS and private practice, and for 17 years was the Honorary Secretary of the British Society for Ecological Medicine, which focuses on the causes of disease and treating through diet, vitamins, and minerals, and through avoiding toxic stress. She's also an honorary member of the GNC and is now the clinical director of CNM as well. And she's going to be talking today about how to live to 100. And we're very, very much looking forward to your talk, Sarah. Thank you.
Thank you, Gillian. Righty-ho, so I will screen share as I've got far too many slides because, but never mind. So I will try and skip through them as quickly as is reasonable. Okay, oops, Daisy. So how do we go to the next slide? Oh, there we go. Okay, so we have to first ask the question, if we're going to address the question, why, how can we live to 100? We have to ask the question why. And so why do we age? Now, you'll be pleased to see this isn't a photograph of me. This is a photograph of somebody who's presumably very, very elderly, but the ANP very kindly put that up for me. And I think that a major reason why we age has to do with mitochondria. And as some of you know, that's my special area of interest, and published 3 papers about mitochondrial function and chronic fatigue syndrome. But so I tend to see life through the mitochondrial and the energy perspective. Now, mitochondria have afforded huge evolutionary gains because they supplied us with abundant energy. And with abundant energy, we can move, we can predate, we can massively improve our food supply, and therefore we can survive as a species. So, so why is it that mitochondria cause problems? And what mitochondria do, as I say, is they deliver energy to the body. They allow us to, they are the engines of our car. So, the analogy that I like to use to explain energy delivery mechanisms to all my patients is the car analogy. So for your car to work, you've got to have the right fuel in the tank, the mitochondrial engine, then the thyroid accelerator pedal and the adrenal gearbox. And the mitochondria are the engines of our car. And if yeast can last forever, yeasts are immortal, but their energy mechanisms are very slow because they don't have mitochondria. And from one molecule of acetate, which is you can get from sugar, fat, or fiber, yeast can only make 2 molecules of ATP, but if you send that through mitochondria and burn that in the presence of oxygen, you can make 32 to 36 molecules of ATP, depending how efficient the system is. So the point here is that we suddenly, with mitochondria, we have an abundance of energy. There we go. I always jump ahead of myself. Sorry about that. But that illustrates the point. Now, the key thing here, as far as mitochondria are concerned, is that if we get our acetate, our fuel for mitochondria, from sugar, we produce a huge number of free radicals in the process of metabolizing that. But by contrast, if we get that acetate molecule from fat or from fiber, very few free radicals. And we know that free radicals accelerate the aging process because they're very damaging. So that obviously gives us the first protocol, which is to eat a low carbohydrate, high fat, high fiber diet. So there we go. This is why mitochondria evolved, because it allows the organism to do more, and by doing more, you can be a more successful organism. That's what they look like. So they are held within cells, they're suspended there with these little microtubules that hold mitochondria where they're needed. What's so fascinating is that if there's a part of the cell that's busy, then the mitochondria can be transported across the cell to where the energy is required. So they don't just sit there still, they whiz all over the place, so they might be needed in the nucleus for synthesizing messenger RNA, they might be needed in the cytosol for other jobs. So they are very mobile and they move around the cells very actively. So that's another view of a mitochondria, and the internal structure is highly folded, and that's in order to produce an enormous surface area on which the little enzymes, complexes 1, 2, 3, and 4, are held for the business of creating ATP, the energy molecule. So that's what it looks like. And the point here is that almost all disease processes that you can imagine involve mitochondria. Now, this is a huge contrast. When I was at medical school in the 1970s, we had 2 years of theoretical work before we went onto the wards. And one of the nasty subjects we had to do was called biochemistry. And we just thought it was such an awful subject. It was the sort of thing that you mugged up the night before on black coffee and dark chocolate biscuits, regurgitated your knowledge onto the exam paper the next morning and hoped you'd done enough to pass. And the reason we thought they were so uninteresting is because they had no clinical application. Having learnt mitochondria at biochemistry, it was never mentioned in the whole of the medical curriculum. And believe you me, in conventional medicine, they are rarely mentioned today now. But they are implicated in almost any disease process that you care to mention. They're primarily responsible, obviously, for power. Mitochondria are determine why we need why we are sexual, why we have males and females, and they are also responsible for the aging process because they deliver energy, and in the process of producing that, free radicals, and it's the free radicals that cause so much damage. So first, power. They supply energy to every cell in the body, not every living cell in the body, not just every cell in the body, every cell in the whole world of nature. So all your trees, plants, dogs, cats, pet frogs, they all use mitochondria. They are a common biological unit. And the point here is if the mitochondria go slow, if they fail for whatever reasons, then that cell will go slow. If the cell goes slow, then the organs will go slow. And we know that mitochondria are centrally involved in not just Alzheimer's, Parkinson's disease, heart disease, but many degenerative conditions. They are centrally involved in cancer. Otto Warburg was the sole recipient of the Nobel Prize for Physiology in 1931, and he came up with the Warburg theory, which is that cancer is a mitochondrial disorder. And cancer cells essentially function best on sugars and simple carbohydrates. And if you consume a diet that is full of sugars and simple carbohydrates, then you're simply feeding those cancer cells. And the starting point to treat any cancer, after the big three of, obviously if you've got an advanced cancer, it's got to be surgery, radiotherapy, chemotherapy. But what next? The key is ketogenic diets. Don't feed those cancer cells with sugar. And of course, if you're going to live to 100, the first thing you want to do is avoid getting cancer. There's a picture of him. I like that picture of him. I think he's awfully good looking. That's beside the point. But that was his hypothesis. And he stated that cancer should be interpreted as a mitochondrial disorder. Another fascinating aspect of mitochondria is they are switched off in cancer cells, because it's mitochondria which control cell suicide. And if you think about it, that makes perfect sense, because if that energy delivery to that cell starts to shut down, then that cell cannot function. And instead of being an asset to the body, it becomes a burden to the body. So if mitochondria go sufficiently slow, then that will switch on cell suicide. So this is the simple reason why low carbohydrate ketogenic diet slows the growth of, arrests cancer growth, and that effect is amplified by high dose vitamin C. And again, there's a fascinating reason for this. Biochemically, vitamin C is very similar to sugar. So much so that all other mammals can make their own vitamin C from sugar. It's a 4-enzyme step to make that happen. So if the cancer cell is being starved of sugar, which is the fuel that it needs to survive, it'll look around for something similar. And if you swamp the body with vitamin C, then the cancer cells will grab the vitamin C and try to use that as the fuel. But of course it can't. The vitamin C gets into the cell and kills it. So that combination of a low sugar, low carbohydrate diet combined with high dose of vitamin C is a fabulous tool for treating cancer. And of course, we're producing cancer cells all the time, just from background radiation, just from background metabolism. It's estimated that every second we suffer about 10,000 DNA mutations. Now, we have a wonderful system of healing and repair that goes along the DNA, it's called DNA repair, goes along the molecule, identifying those abnormalities and correcting them. But, every so often you're going to find one of those mutations is going to impact on cell growth, and suddenly you're going to get a cancer cell developed. Again, it's estimated that any moment we all have about 7 million cancer cells circulating in our body. And it's the job of the immune system to recognize those cancer cells, see that they're abnormal, and nip them in the bud, knock them off before they become a problem. But if you are loaded with sugars and carbohydrates, if you're running a high blood sugar, as in diabetes, then you're going to be feeding those cells. And suddenly you will get to the stage where those cells are being fed faster and replicating quicker, faster than the immune system can knock them off. So by going on a ketogenic diet and not feeding those cancer cells, you're massively going to tip things in your favor. Sex, I'm not going to go into that, but there's if you're interested in that, then read Professor Nick Lane's book, Mitochondria, Power, Sex and Suicide. Fabulous read, one of my favorite books, teaches you so much about it. So I'm going to skip through that because that's not relevant. Oh yeah, okay, there we go. I always jump ahead of myself. It's mitochondria that are essential for cell suicide and therefore for fetal development. Because as the egg develops, there are more cells born than survive, and it's up to the mitochondria to control cell suicide and thereby prune those cells that we don't need. Oh, there's the book. That's the recommended reading. That's my book that a quick skip through how mitochondria work. My daughter thought of this title, which I thought was lovely, From the Naked Ape to the Knackered Ape, because that's what we are. When I was working general practice in the 1980s, it was estimated then that 40% of all consultations had an element of TATT, tired all the time. Now, patients don't go and see their GPs with tired all the time symptoms anymore because they know the GPs are useless at treating it. But us naturopathic doctors, we're very good at treating fatigues, and we're the doctors that should be consulted. But you can see from this picture, this is the evolutionary progression to upright man, but most look like this, and that's the ultimate couch potato. And we know that those people who are overweight, addicted either to food or to alcohol or to cigarettes or to whatever, they're the ones that die young from various diseases. So the point is we age at the rate of our mitochondria. So the key to all this is to look after your mitochondria. Now, the maximal biological age we have is about 120 years. That's what we should all be aiming for. This is a lovely example of how mitochondria are implicated in the aging process, because Dolly the sheep, as you all know, was the first sheep to be genetically engineered. So she had a single parent. She was grown from her mother. She was a clone grown from her mother's mammary cells. Now, the life expectancy of a sheep is about 12 years. And Dolly the sheep, when she was born, her mother was about 6 years of age. And she acquired her mother's mitochondria, which from the mammary glands were mitochondria, but they were already 6 years old. So she was born with aged mitochondria. And what was so interesting is that she died age 6 from leukemia. And that's a disease that you expect to get in sheep at a much greater age. So it's another nice little illustration of how mitochondria are vital for determining the aging process. So the rate of this, say, is probably determined by free radical damage. We can reduce free radical production with a ketogenic diet, which, as you all know, I'm a great advocate of. We increase free radical production with high carbohydrate diets. The problem with these diets is they're addictive, they're cheap, they're convenient, and we get because they're addictive, we get an immediate hit from them, and it's difficult getting people off their high carbohydrate diets. We can increase the free radical damage with toxins, radiation, pesticides, toxic metals, all those sort of things. And we can reduce the free radical damage by using natural substances to mop these up. So this is the kind of overall strategy if you want to live to a great age. So can it be done? Yes. Jean Calment is the example I always quote. She lived to the age of 122. So we have to ask ourselves, well, what did she do? You know, what was it that made the difference? What was it that allowed her to live to that great age? Well, the first thing is she had a good family history. For your longevity, you want to look at the female line, because mitochondria are all female. Mitochondria come down the female line. They are present in the egg, in the oocyte. There are about 100,000 mitochondria in the female oocyte prior to fertilization. By contrast, the male sperm have about 100 mitochondria. And they're male mitochondria because they come from the male. And as the male sperm fertilizes the egg, and of course the male sperm is minuscule compared to the egg, as it fertilizes the egg, the female mitochondria kill off the male mitochondria. So I say mitochondria come down the female line. Now, there are one or two very rare exceptions to that, but the point here, largely speaking, that is the case. And the point here, look to your maternal bloodlines to determine how good your mitochondria are and how long you're going to live. Now, unfortunately, that's curtains for me, because my mother, grandmother, and great-grandmother all died before they got to 60. So I'm on borrowed time already. So I'm trying to make the most of it. Now, she came from a wealthy family and she didn't have to work. Now, that helps a lot. Work is stressful. And how do we deal with stress? One of the ways we deal with stress is we turn to addiction. We use sugar, carbohydrates, coffee, chocolate, alcohol to deal with stress. It's short-term pain, long-term gain. So wealthy families never had to work. She was French. She loved food. And of course, the food in France is superb. In fact, I've just been reading a fascinating book about how food was delivered to France in the late 19th centuries. And it was produced in small holdings run by French maraîchers. And they took the horse manure and straw that came out of the transport industry in Paris and grew foods intensively on horse manure, organic, and they used cloches to grow these foods very quickly. And they supplied the whole of Paris with the most excellent vegetables that and fruits and nuts and seeds and the like. They were fantastic. So good food. She was physically active. She was slim. She took up fencing at 95. The story I love about her is in France, there's a system as you get older, if you want to downsize, you can take up a reverse mortgage. And what that means is that you sell your flat to somebody for a fixed sum, which is called a bouquet. And then on top of that, they pay you a monthly allowance for your lifetime. So you can then downsize, but still have an income. And she sold her Parisian flat to her lawyer for a bouquet, which allowed her to buy a smaller flat. And he then had to go on paying her 2,500 francs a month until her death. And the funny thing is she outlived her lawyer. So he never got to live in her posh French flat. But his widow continued the payments. So, and as I say, there you can see, she gave up public speaking at 120. She credited a long life to a diet of raw eggs and being single. I can identify with that. Families can be very stressful. But there you can see she had very good genes. Her sisters lived to 100 and her mother to 91. Again, supports the theory or the hypothesis that mitochondria is central to the aging process. So this is what we have to do to slow the aging process, is you look after your mitochondria. And that has to do with diet, micronutrients, sleep, di-da. You can read as well as I can. So let's skip through the important things. How are we doing for time? Oh, not too bad. Okay, so these are the main aspects of diet which cause fatigue and accelerate the aging process. And the single biggest one are the high levels of sugar and fruit sugar, and we'll talk about that in a moment, and refined carbohydrates. Addictions, as I've mentioned, if somebody has to use addiction in order to keep going, and it doesn't matter if it's caffeine, sugar, alcohol, same applies. Micronutrient deficient diets, and all Western diets are micronutrient deficient, simply because there's a one-way cycle of micronutrients from the soil into plants and also into us, and we discard them. We don't recycle human compost back onto the soils again. Allergies and intolerance, which can result in malabsorption. Fermenting gut, one of my favorite subjects. And then, of course, the chemical overloads that we all know so well about. Because all those things create free radicals. And John Yudkin was the first scientist, really, to flag up the problems of sugar. And he wrote a book, Pure, White and Deadly. And addictions, I've talked about that, mentioned that, but Western lifestyles are intrinsically addictive. And the awful thing is, doctors simply add to that addictive load. And prescription drugs, so many prescription drugs, are addictive. The way that I like to explain this to patients or to people is that we work because we have an efficient biochemistry. And for that biochemistry to function well, we want it to move as freely and as frictionlessly as is possible. And most drugs work by blocking enzyme systems, by inhibiting. So drugs increase the friction in the system. But by contrast, micronutrients, essential fatty acids, oils, they assist, they work by facilitating biochemical processes. And so they work by reducing the friction in the system. So what this means is that the more drugs you take, the greater the frictions in the system, the greater the potential for side effects, and therefore biochemistry, including mitochondria, will go slow. But by contrast with micronutrients, they work together. They work symbiotically, and each one facilitates the other. So arguably, the more and the greater the variety of micronutrients we take, and of course, if we can get those from food, that's ideal, then the better. So doctors are dangerous people. I don't mind saying that. I've had a whole General Medical Council hearing about that, which I was delighted to win, because doctors are potentially very dangerous. And what's so fascinating is that when doctors go on strike, death rates fall. And this has been illustrated in at least, well, here we are, 7 articles, 5 strikes, and without fail, all reported that mortality either stayed the same or decreased during and after the strike. One of these is a lovely study about cardiology patients, people coming into a hospital with acute chest pain. Now, when there's a cardiological conference, of course, all the consultants and many of the senior registrars are at that conference. And so what that means is that when those patients come into hospital, the interventions they receive are far less and far fewer because there aren't the doctors around to do it. And guess what? Death rates fall. Okay, that's what happens when you are running a high blood sugar, because mitochondria do not like it when blood sugar levels are fluctuating. We do have to have a certain amount of sugar in the bloodstream. It is an essential. We do need sugar for the purposes of making ATP. We do need sugar for making the molecule ATP, that is, for making RNA and for making DNA, and also for detoxification. But we need very little of it. And the problem is that when we have too much sugar, mitochondria, because sugar is so dangerous, mitochondria will always burn off sugar before it switches to ketones and to fat and to acetate groups. And when that happens, if you have too much sugar in there, you're literally flooding the engine, and that causes fatigue. And of course, we all know that diabetes often presents with fatigue. Then there's an optimal amount, and then the blood sugar runs low, and that causes poor energy delivery mechanisms. So people who are running their bodies on sugars and carbohydrates with fluctuating blood sugars will inevitably become fatigued. Those are the symptoms of hypoglycemia. It's a clinical diagnosis. You don't need tests to make it. Those are the common symptoms. I'm not going to go through those, but I'm quite sure you're familiar with them. But it's very easy to diagnose the carbohydrate or the sugar addict. In fact, the quickest way to do it is just to ask the person, what do you have for breakfast? And if breakfast is, a sweet drink, orange juice, toast, muesli, porridge, then you can be pretty sure they are running their body on carbohydrates. Okay. And as I say, this is a fascinating study that was commissioned by the US Army. Now, what was so interesting about the Gulf War, 1991, is that many of the fatalities in the Allied soldiers were from friendly fire. So they asked themselves, well, why are we shooting our own soldiers? What's going wrong here? Now, the troops, when the war began, were told, we cannot guarantee to supply you for 5 days. You've got to carry with you everything that you need for 5 days. Now, if you're a soldier in a frontline troop, you make sure you never run out of ammunition. So these soldiers loaded up with ammunition and weapons and cut at the expense of the food that they were carrying. And what the upshot was, by day 3, by day 4, by day 5, they were hypoglycemic. And when you are hypoglycemic, you make bad decisions. And many of those bad decisions involved, friendly fire. So the US Army commissioned Dr. Kira Clark of the Oxford University to determine what the most efficient fuel was that they had to carry to power frontline soldiers. And to cut a very long story short, she was doing work, and it just so happened she was in a laboratory who was synthesizing beta-hydroxybutyric acid. Now, beta-hydroxybutyric acid is the most abundant ketone in the body. And she then went on to test this on elite athletes, Olympic athletes at the top of their tree. And what was so fascinating is by simply switching over to this beta-hydroxybutyric acid, this ketone fuel, the endurance athletes improved their performance between 7 and 15%. Now, and she, in fact, one of her husband was one such, and I just wondered if that's explained why we did so well at the 2016 Olympics in South America, because they got everybody out there early and got them onto this drink. I don't know if that's the case, but we did do awfully well at those Olympics, which was immediately after her research. So the bottom line is we should all be eating a paleo-ketogenic diet. I'm not going to go through that in depth because you all know what it is, but essentially it's cutting out the sugars and the carbohydrates. And this is a new little snippet of information that has come out from this, which is further reason why you should be careful with sugars and fruit sugar, because fructose is very pernicious. And this was all done by nephrologists from Colorado, Richard Johnson. And you ask the question, well, why should a nephrologist be interested in fructose? And the reason is because, of course, diabetics have a very high risk of renal disease and kidney disease. Anyway, he went into the biochemistry of this, and essentially about 65 million years ago, we lost, and I beg your pardon, about 50 million years ago, we lost an enzyme uricase, which normally breaks down uric acid. So what this means is we have significantly higher levels of uric acid in humans than other animals. Now, fructose is measured to uric acid, and there's a direct link between fructose consumption and uric acid. Now, we then have to ask the question, why should this have happened? And the reason is because uric acid switches down on the laying down of fat. And of course, if we have lots of fruit in the autumn, we get fat, and that allows us to survive winter. So this is a survival technique that evolved about 50 million years ago that helped us get through the winter, but is now playing against us because we have so much food. We have so much fructose in our diet. Oh, there we go. I've jumped ahead of ourselves, but the average level of uric acid has doubled recently. I think levels should be certainly below 300 micromoles per litre. So again, if you have blood tests done by your doctor, look at the uric acid. Very often it's up to 450 and the doctor says, oh, that's fine, that's normal. No. The higher it is, the less healthier you are. So, and you get uric acid down 80% of the time by cutting out the fruit. about 20% of uric acid comes from high protein, high purine diets. So again, the paleo-ketogenic diet is not a high protein diet. It's not the Atkins diet. You're not eating 10 beef steaks a day. It's a normal amount of protein. So again, the PK diet covers the problems of uric acid and fructose. And there we go, neurocognitive damage. Alzheimer's disease or dementia is now being called type 3 diabetes. Some of you may like to look at Patrick Holden's work. He's got a wonderful website called Food for the Brain. He's done some terrific research, and essentially he is saying that Alzheimer's disease, dementia is 99% preventable. And the three big things are, first of all, low carbohydrate diet, paleo-ketogenic. Secondly, check your homocysteine. Now, this is a blood test that can be easily done on a do-it-yourself blood test, and I like to see the levels below 10. And if your homocysteine is high, that massively increases your risk of arterial and vascular disease. That's because homocysteine is a marker of the methylation cycle. Without good methylation, you can't heal and repair. And the third thing are fish oils. So do those three things and you will not die with dementia or from dementia. That's got to be good. Okay, fat is good. And in nature, say there's no such thing as a bad fat. And the only problems with fat is when we cook them and when we cook oils. It's the oils that are a problem. Saturated fats are completely safe, tough fats, and they make wonderful fuels for the body. So for cooking, use lard, coconut oil, palm oil, no problem at all. It's the unsaturated fats that are a problem. So the way I explain it to people is that unsaturated fats mean that you're missing a hydrogen ion, and therefore you have a double bond. So there's a kink. So that is an omega-3 fat, an omega-3 oil with one kink. That's an omega-6 oil with two kinks, and an omega-9 oil has got three kinks. So it's bent like a boomerang. And in nature, these are all left-handed oils which fit our enzyme systems and are essential for healthy cell membranes. But if you hydrogenate them, i.e. you make margarine, or you heat them, then you will flip them into right-handed fats, which are called trans fats, and those do not fit. They clog up the system and drive pathology. So all oils should be cold pressed, kept in the fridge, and consumed cold. Drizzle them on your French dressing, drizzle them on your vegetables or whatever. Only cook with saturated fats. Olive oil is not a fat for cooking. You're doing more damage with that. There we go. So don't only cook with saturated fats. I was also delighted to read in Bill Bryson's book that the fish and chip shop that won the prize for the best flavored chips, they use beef lard for cooking their chips in. Okay, and again, we can reverse Alzheimer's disease with the ketogenic diet. There's the reference for that. This is work by Dale Bredesen in California. Oops, a daisy. Oh, there we go. Cancer can be used to treat, you can treat cancer with a ketogenic diet in above everything else. And again, the red bit is the highlighted bit. I remember there's a wonderful, fascinating case in New Scientist of a young boy with malignant glioblastoma, had all the treatments, nothing more could be done, very poor prognosis, went on a ketogenic diet and was alive 10 years later when this article was written. So that's a particular benefit for brain tumors. Sleep. Quality sleep is so important. You have to take as much care of your sleep as your diet. And we should aim for, about 8 to 9 hours sleep, more in winter, less in summer. Exercise, again, we all know that exercise is really important. Oh gosh, somehow or another, the wrong thing got flipped into that, but never mind. And guess what? Primitive people eating primitive diets are physically fit. I don't have I've never seen a fat centenarian. All my patients that I've had dealings with who are 100, they're all slim. So hang on, things have jumped around a little bit. Sorry about that. But exercise, nobody likes doing exercise. Well, very few people like doing exercise because it's hard work and it's painful. You can do too much exercise. And a friend of mine is an elite athlete and does these ridiculous Ironman competitions where they do outrageously physically active things. And when we ran his bloods, there are a lot of abnormalities there. So just because you are physically fit doesn't mean that you are healthy. And the most efficient form of exercise is high intensity interval training. And you have to do workups with short, powerful bursts of energy like press-ups or squats that last a maximum of maybe 3 or 4 minutes. And you have to do sufficient to make the muscles ache. Because if you don't ache, you don't get lactic acid, because the aching of muscles is caused by lactic acid, and lactic acid stimulate more mitochondria. And when we age, there's a natural tendency to lose muscle. It's called sarcolepsy. And losing muscle is a symptom of being old. And we can slow that down. We can't prevent it entirely, but we can slow that down with exercise. But don't go sprinting, don't go anything like that, because then you will tear muscles and tear tendons. Slow, powerful exercises is the key. I'm very lucky. I do that on my horse. So that's my horse getting fit in a few minutes a week. Okay, micronutrient deficiencies, I mentioned that. We are wasting, we're not recycling human waste, and therefore all foods are micronutrient deficient. And when we have drugs, social drugs, addictions, prescription drugs, we need more micronutrients to deal with those. And therefore it's my view that we should all take a basic package of nutritional supplements. This is a picture of Weston Price, who looks at nutrition, physical degeneration, and I'm sure you're all very familiar with his work, but these are just wonderful pictures. These are primitive people who were brought up on a diet, a normal primitive diet, and they've got lovely dental arches in all 3 dimensions, from that direction, forward and backwards, and side to side. The upper part of the mouth needs to be a hemisphere effectively, and then as we use the muscles in our jaw, that pulls the jaw forward. So we've got beautiful dental arches with okay, she's broken a tooth, but these are all got lovely teeth. And by contrast, as soon as these people moved on to Western diets with high sugar, here's you've got the beautiful dental arches. Here you can see the teeth crowded, rotten, and decayed. And the commonest operation in children today under the age of 6 is emergency tooth removal because they've got rotten teeth, because they're terrible diets. That, I believe, is the minimal of minerals that we should be consuming. And as I say, if you've got a deficiency of anything, of any micronutrient, then the body's going to go slow. And if the immune system goes slow, you're going to get infections. The biochemistry goes slow, and of course, mitochondria are stuffed with biochemistry, dee-da. And again, increasing susceptibility to side effects. The one you probably all are familiar with is the thalidomide story and phocomelia. And what was so interesting, these were children born with flipper limbs. And what was so interesting is that when they tried to reproduce this in rats, they would feed rats throughout pregnancy the drug thalidomide. All the babies are born healthy. It was only when they put the mothers, the kits of the mother rats, on micronutrient deficient diets that they saw the abnormality. So the point here is having jolly good nutrition, the best food you can eat, a good range of micronutrients in physiological doses. You will greatly protect yourself against the toxins that are an inevitable part, unfortunately, of modern life. Vitamin D, again, primitive woman trotting around in Africa would have had 10 hours of sunshine, 12 hours of sunshine, maybe every day. And would have had lovely high levels of vitamin D. It's impossible to get adequate amounts of vitamin D living in our climate. There's no sunshine today. And guess what? I'm not a pretty sight in a bikini either. So we all need to take at least 10,000 IU of vitamin D daily. That's what happens if you don't take it. It's also a major risk factor for osteoporosis. And again, freedom from toxins, because the more we can do to reduce our toxic stress, the better. And the major exposures, are within our own control to sort out. We've talked about sugars, upper fermenting gut. When they get fermented, you get lots of toxins as a result of that. Additives, pollutants, dentists, doctors, and, I've done endless tests, fat biopsies, blood tests, urine tests. I've never seen a normal test. Everybody carries a toxic load without failure. I think I've got a few examples of these. These are DNA adducts tests. This is a patient of mine who actually had breast cancer, chronic lymphatic leukemia, and she had very high levels of lindane and also nickel, both known carcinogens. Lindane from timber treatments. Nickel, well, there's many sources of nickel, but a major one that people forget are piercings. Many jewelers use nickel as a metal because it's very malleable and it combines with other metals very readily. But, if you've got an earring or a piercing, you're just drizzling nickel into your body, and nickel is a known carcinogen. This is one of pesticides, but as you can see here, a whole range of nasty toxic compounds. And I say we all have some of these. The normal result should be 0, of course. More biolab, less. This is again mitochondrial membrane protein studies. This is how chemicals interfere with mitochondria, or one of the ways in which they interfere with mitochondria. So I'm going to skip through these. This is my special area of interest. I mentioned this earlier. This was the important part of the paper, the first paper, looking at mitochondrial energy score, which we could assess from ATP studies, and chronic fatigue. There was a straight line relationship. So the sicker you were, the worse your mitochondrial function, and vice versa. So we know it's centrally important in chronic fatigue syndrome. And the tests also tell us what the problems are. And this is how we can correct mitochondria function very effectively with magnesium, ribose, B3, CoQ10, and so on. And arguably, as we age, we should all be taking something for our mitochondria. And my view is the most important would be magnesium, 200 milligrams a day, vitamin B3, 1500 milligrams a day, CoQ10, 100 milligrams daily. They are the 3 most important. More details in that. I've just rewritten that book, so it's come out as a 2nd edition. And then, of course, avoid infection, because we now know that infections, drive all pathologies. All pathologies have an infectious driver. This is a chunk out of my book, The Infection Game. I'm not going to go through the whole point, but we know dementia is associated with all these microbes: Lyme disease, toxoplasmosis, herpes viruses, cytomegalovirus, dee-da. Armin laboratories do fabulous screening tests, and if I had a patient who was presenting with this sort of condition, then I would be very interested in doing screening tests to see if there's anything that we could really tackle as a matter of urgency. But we all know about syphilis causing general paralysis of the insane, but mycoplasma, HIV, of course, is associated with the dementia, Jakob-Creutzfeldt's disease, Helicobacter pylori, which is part of the fermenting gut. So the point is, don't get infections, avoid the damn things. And how do we avoid the damn things? Well, first of all, don't get exposed to them. And they're the obvious things. But the good quality skin, of course, you don't want the infections coming through the skin. The paleoketogen, microbes can only, bacteria and yeast in particular, and to viruses to a certain extent, they love sugar and carbohydrates. So often the diagnosis of diabetes is picked up because suddenly somebody who's normally well starts to get skin infections, urinary tract infections, chest infections, and it's because their body is saturated with sugar. And these microbes are going, yum, yum, we'll have some of that. So a low carbohydrate keto diet is highly protective against infections. Vitamin D, we talked about that. C, humans can't synthesize their own vitamin C, so we have to consume it, and we should all be having at least 3, 4, 5 grams of vitamin C a day. And all these are far more effective than vaccination. An acid stomach, again, is an essential defense against disease. And if you are eating a high sugar, high carbohydrate diet, you overwhelm the ability of the stomach, the upper gut, to sterilize that, and that becomes a fermenting gut. And if you've got an upper fermenting gut, then the lining of the stomach is inflamed, and you can no longer concentrate acid in that stomach. And remember, 90% of all infections come in through the mouth and the nose. Either we swallow them and they end up in the stomach where they should be killed by an acid bath, or we inhale them, those microbes get stuck in the respiratory tract, sticky mucus, coughed up and swallowed. And again, should end up in an acid stomach. So looking after your gut with all these interventions is very important. There I detail the infection game, and I was very pleased with myself with the design, because the infection game, it's like a game of chess. You know, we have these black invaders who are highly intelligent. Don't think bacteria, yeast and fungi are stupid. They're not. They are clever, and they have the most fantastic ways of invading our body and making themselves at home. But by contrast, on the white side, we have our immune system, which is also fantastically intelligent. And the infection game, it really is like a game of chess. Now, it's a game we know we're always going to lose, and we lose it. And when we lose it, we die, of course. But we want to play that game as well as we possibly can, because this game, played well and intelligently, will protect you from infection and will protect you from death. Doctors are dangerous people. I've mentioned that. Oh, jumped ahead of myself. Here's the starting benefits of cardiology meetings. Medical error is the third leading cause of death in the USA. There's the reference for that, either through drug side effects, overdoses, drug interactions, misdiagnosis, or whatever. These are my pet hates within the medical profession. I'm not going to read those out because you're quite capable of reading, because all of these are symptom suppression things, and many of these issues drive inflammation and pathology. Sight. Now, I'm just going to talk about this very quickly, because sight is so important. It's such a vital sense. And you know, if I went blind, oh, I would hate that. But you can stop eye pathology evolving just by these very simple methods. First of all, low carbohydrate diet. Secondly, high dose vitamin C. But thirdly, avoid wearing spectacles, because they make the eyes weak. And to explain that quickly, if you look at something in the distance, then the eye becomes a golf ball shape, it becomes a spherical shape. And then when you look at something close to it, the lens fattens in order to focus the light at the back of the eye. But it's not just the lens that fattens. The eyeball elongates, it becomes egg-shaped. And so when we focus, it's not just the lens that changes shape, it's the whole of the eye goes from a golf ball shape for looking at things in the distance to egg-shaped for looking at things close to. And if you keep the eye tissues soft, and you do that by avoiding free radicals, all the things we talked about, and vitamin C, low carbohydrate diet, and then you don't use glasses, then you keep the eye working. And by doing that, you protect yourself from macular degeneration, from cataracts, and from glaucoma. So these are the problems of an egg-shaped eyeball, which I'm not going to read out, but you can read. And this is, if you're already wearing glasses, then what you do is you do all the things we've talked about: PK diet, antioxidants, vitamin C. Get yourself a pair of glasses that are half a diopter too weak, and then your eyes will start to get strong. And you keep going until you no longer need these. So I have no longer need glasses for reading. I've reversed my myopia when I discovered all this. I learned much of this in Dr. Jose Mendonca, but there are some wonderful books written on the subject. So in order to keep fit, you have to work at it. It doesn't come for nothing. You can't just, glug down a few pills and think that's going to do the job. And these are all the things that you're going to do. And I do put this into practice. Now, this is a picture of an old boy who I look after, Tony Ditcham. He lives in the annex over there. Of course, I feed him, so he has a paleo-ketogenic diet. This is him on his 100th birthday. And this is him swimming in my eco pool on his 100th birthday. And this is a picture of him looking over my horse's stable, having given me a hand mucking it out. So, it's perfectly possible to leave. Now, he does have very good genes, it has to be said. His mother, he has relatives who live to 100, and many of his family live to 90. So it is possible. And of course, it's never too late to start. If you're leading an unhealthy lifestyle, you will age quickly. If you're leading a healthy lifestyle, you'll age more slowly. But at any moment, you can extend your longevity by putting all this stuff in place. The details in there. Phew. Have I done it in an hour? I think just 5 minutes left, Gillian. Sorry, I might have gobbled that, but let me stop sharing.
No,
And if you've got any questions, now's your chance.
that was fantastic. Thank you very, very much indeed. Thank you.
I have a question, actually, if I may ask.
Of course.
I believe, as a biologist become naturopath, that mitochondria were once organisms in themselves.
Correct.
Yeah, and that they are actually the ultimate symbiotic part of our body in many ways.
Absolutely.
Yeah. Yeah.
And the whole, I mean, that happened very early on in evolution, billions of years ago. And but an interesting point about that is mitochondria are bacteria. And there are two important clinical issues that arise from this. The first is that if you give somebody supplements for their mitochondria and you haven't sorted out their upper fermenting gut, they're still eating sugars and carbohydrates, then you will simply feed those bacteria in the gut and make the upper fermenting gut worse and the malabsorption worse. And the other interesting point has to do with antibiotics, because antibiotics work by inhibiting bacterial biochemistry, and they will have the same impacts on mitochondria. So some antibiotics can be particularly toxic to mitochondria, and ciprofloxacin is probably one of the worst. Unfortunately, it's a fabulous antibiotic, but if it messes up your mitochondria en route, well, that's not so good either.
Interesting. Thank you.
Could you just explain a little bit more, Sarah, why human beings lost the ability to use vitamin C, if there is a beneficial reason?
Well, that's a very, very good question. And I don't know what the beneficial reason was. It probably happened about 65 million years ago, and it's humans, fruit bats and guinea pigs suddenly, for some reason, lost the ability to make vitamin C. But at that time, they were living in Africa and eating a diet that was rich in vitamin C. And so they could get away with it because they could obtain vitamin C from their diet. Now, of course, all that evolution cares about is getting us to childbearing age. Now, I'm on the evolutionary scrap heap. I've had my kids, and if they propagate my genes, they may or they may not, but I can't do anything more about it myself. I'm 50. So if I die tomorrow, nature doesn't care and evolution doesn't care. I'm evolutionary junk. But and therefore, if I die of vitamin C deficiency, that doesn't matter. But we all know that vitamin C is so important to protect us against so many diseases. So, I use my brain and I go and I buy vitamin C and I take about, 5 grams a day. And I do that because I know that will improve my chances of being well and living my life to its full, and not getting cancer and not getting dementia and not getting eye disease and all the rest. But it's a very good question. And I don't know if there is an evolutionary bonus to not being able to synthesize our own vitamin C, but it's just we could get away with it at the time, and we did.
Because I always like to look at health from the point of view of the body is always trying its very, very best to keep us alive. And
correct,
genetic differences that evolve.
Yes,
sometimes do have a reason, but
me too. And whenever I have a difficult question, I always go back to first principles and evolutionary biology to see if I can see a reason for that. But I can't see a good reason for, say, vitamin C, the ability to synthesize that being lost. But I say, so long as it gets to childbearing age, it doesn't matter.
And there is one gene again, the G6PD gene, I think, that prevents us from being able to, you can get hemolysis if too much vitamin C is used as an infusion. Does that matter with oral vitamin C?
No, I really don't think so. And believe you me, I've searched and searched and searched the literature, and I cannot find any evidence that that's a problem. So it does make vitamin C very safe. The only group of people who will maybe not tolerate vitamin C is often women who have irritable bladders or perineal pain, vulval pain, which is associated with oxalates. And vitamin C can make that worse, but otherwise, it's gloriously safe stuff, and and I like everybody to take about 5 grams a day.
Okay, thank you.
I think different people have different tolerances to vitamin C because it reaches bowel tolerance at a certain level.
Correct. It would be unusual to get back to bowel tolerance at 5 grams. But I mean, obviously, I never try anything on my patients without trying it on me first. And when I first started getting interested in vitamin C, I'm ashamed to say I wasn't doing a paleo-ketogenic diet because I didn't know about it then. But I could tolerate 30 grams a day without getting any bowel tolerance symptoms whatsoever. And but then that fairly rapidly came down. And now my bowel tolerance actually is about 4 grams. And I think it's because the body takes what it needs, uses what vitamin C it takes from the gut, uses it systemically. The reason it doesn't impact on the large bowel is because it's excreted through the urine. And that's why there's no impact on the microbiome. But so I'm hoping that that's a sign that, I'm reasonably healthy. But if a bowel tolerance is very high, then that person is not healthy because the body's grabbing vitamin C to do a job, whether that's killing microbes in the upper gut, whether it's detoxifying, whether it's improving antioxidant status, whether it's dealing with chronic infection or whatever. But it's a fabulously useful tool.
And one other little question, if I may, is do you administer or get people to take 5-hydroxybutyric acid? Because it's naturally produced as one of the fatty acids in the gut by fermentation, but it is the smelliest stuff I can imagine. It absolutely stinks. Being in an agricultural area, we get butyric silage sometimes produced, and you can smell it miles away.
No, I never use it. But the point is if you're in ketosis, you're making your own hydroxybutyric acid, beta-hydroxybutyric acid, and that's the desirable fuel to run on. So when we get fuel from fat or from fiber, it produces 3 ketones. Beta-hydroxybutyric acid is the main one. That's the main one we use as fuel. But we also get acetone, and that is volatile, and that is excreted in breath. So you can, so sometimes people have complained of pear drop smell, but that acetone excreted in breath is quite a good way of measuring to see if you're in ketosis with a ketone breath meter. And then the other ketone, acetoacetate, is excreted in urine. So we pee that out. And again, a good way to test if you're in ketosis is to pee on the keto sticks. And if the pink goes to purple, then you are producing some ketones. I'd just like to add that in the long term, as the body gets more efficient and better at running on ketones, very often the urine sticks show false negative, i.e. you are in ketosis, but you've managed to link energy delivery to energy demands very closely, so you're not wasting ketones in urine as acetoacetate.
C8, I think, caprylic acid is the best precursor, isn't it, to beta-hydroxybutyrate? So one way to sort of kick people into ketosis, or at least to allow fats into their mitochondria when that seems to be a problem, is often to give them C8.
Which of course is rich in coconut oil.
Yes.
So and coconut oil is one of my favorite things I use. I love to cook with coconut oil. The coconut milks are delicious. If you get coconut milk, just check, because some are quite high in sugars, but the one I like to use is only 2% carbohydrates, and that's what goes on my berries for my pudding after main course. Thank
you. Peter, you looked as though you
yeah, I did have. I just could ask you so many questions, Sarah. Thank you very much for talking. But we don't have time. But and this may be a very, very short question, or it may be rather a complicated one. I'll leave that to you. But we will get asked, and I'm sure you have been many times, and I am always being asked, how does a plant-based preference eater become a keto eater?
Well, it is possible. And I do, for vegetarians, I have several vegetarians who do a keto diet. I even have one vegan who does a keto diet. So it is possible, but it's just harder work. I mean, again, I always take the evolutionary biology approach, which is that humans evolved as omnivores, having some animal protein. I'm not a fan of dairy products, animal protein and eggs. I mean, I have to say I share the same animal concerns as vegans do. And of course, I live in a very privileged position because I have a little small holding. I have my own pigs, my own ducks, my own hens. I have my own garden, so I grow all my own stuff. And every mouthful of meat that I have comes from an animal that's had a very good life. So it is possible. but difficult to be vegan and eat a keto diet. But you should aim to do that, because we know that sugars and carbohydrates, are potentially so damaging to the body.
Thank you. Very helpful.
Thank you. We're right on time, and thank you very much indeed, Sarah, on behalf of the GNC, for giving us this wonderful webinar on how to live to 100.
My pleasure. If you've got any additional questions, then fire them through to me by email, and I will try and send you some relevant and useful information.
Thank you. Could you maybe give us your email address for people to do that?
Yeah, it's just office@doctor, and it's the long doctor, DOCTOR, drmyhill.co.uk. Or if you just Google Myhill, my website comes up, and the contact details are all on there.
Thank you very much.
Thank you. Right, I stopped recording. So
thank you, Sarah. So